All right, so these are the notes for graphing quadratic inequalities. So here it says a quadratic inequality in two variables can be written in one of the following forms where a, b, and c are real numbers and a cannot equal 0. So you notice they look like quadratic functions in standard form, except they're replacing the equal sign with our inequalities less than, greater than, less than equal to, and greater than equal to. So the graph of any such inequality consists of all solutions x, y, so they're ordered pairs of the inequality. Okay, so recall graphing with inequalities here. So if you recall from when we did systems of linear inequalities, if the line was dashed and it was shaded above, then it is going to be greater than. If it was dashed and shaded below, it would be less than. And above in solid is going to be greater than, and you add that equal bar. And below in solid is going to be less than and equal to. And you can see over here, like dash and above, solid and below. So those are just some examples of what it would look like. We tend to do things a little bit differently when we're doing these just because parabolas can open up and down. So I'm gonna go and walk you through these steps. We'll do a couple of examples, then let you see. All right, so to graph a quadratic inequality in one of the following forms, follow these steps. So graph the parabola with the equation y equals ax squared plus bx plus c, then use your inequality symbol to determine if your parabola is solid or dashed. So pretty much in this part right here, for step one, remember you got to get your vertex. So if it's in standard form, the first thing you should do is get your axis of symmetry. So x equals the opposite of b over 2a. Then after you do that, you're going to find your vertex. And we know that this is the x value of the vertex. And to get the y value, we take this and we plug it into our function here to get our y value. Then we're going to use the pattern, 1, 3, 5, and 7 if necessary. And then we're going to multiply it by whatever the a value is. And then we're going to use that to make the rest of our graph. Okay. Step 2, after you graph your quadratic function, whether it's solid or dashed, then you're going to test a point, x, y, to determine if it is a solution to the inequality. Now, I will tell you this right now. The one point that I always tend to use is going to be 0, 0. Now, I use that point as long as the quadratic function does not cross through the origin. If it does, then I have to pick a different point like 1, 0 or negative 1, 0. But I try to use 0, 0 just because it makes it a lot easier to do. And then after you test that point, shade the region that includes your test point if it is a solution, step 2. So if I plug in 0, 0 into the quadratic inequality and it's true, then I shade the region where the point is. If it's on the outside of the parabola, I shade on the outside. If it was the inside, I shade on the inside. Now, it says shade the region that does not include your test point if it is not a solution, okay? So if you test that point and you test it on the outside of the parabola and it's false, then you would shade inside and vice versa the other way as well, okay? So let's go ahead and go through this example real quick and you'll see how this works. Okay, so the first thing I'm gonna do, I'm going to look at my quadratic function and I am going to first find my vertex. So here we're going to identify a, b, and c. So in front of x squared is negative 1. So a is negative 1, b is in front of x, which is negative 2, and c is the constant, which is negative 1. Okay. Now from here, I'm going to do that formula, x equals opposite of b. So I'm using this formula right here. X equals the opposite of b. So the opposite of negative 2 is 2 divided by 2 times a is negative 1. And that's 2 divided by negative 2, which is going to be negative 1. Now, for my vertex, negative 1, comma, because up here I told you that the axis of symmetry is the x value of the vertex, and you should recall that. Now, to get the y value, we're going to take negative 1 and we're going to plug it into this function for x. So I'm going to change it to y equals. Let me have negative parentheses negative 1 squared minus 2 times negative 1 minus 1. So y equals, now you can use a calculator for this part. I'm going to do it by hand. So here we're going to get, let's see, 1 sec here. All right, PIMDAS, so negative 1 squared is 1. We have a negative in front, so that makes it negative 1. Negative 2 times negative 1 is positive 2 and minus 1. So 2 minus 1 is 0. So my vertex right here is at negative 1, comma 0. So I'm going to go to my graph and I'm going to plot negative 1, 0. Okay. Now I'm going to identify my a value because I said that's another thing we need to know. So here a is negative 1. I'll just write that right here. Now from here, we have 1, 3, 5, and if necessary, you have more points, you can put 7. Now we're going to take each of our 1, 3, 5, that pattern, and we're going to multiply it by the a value. And then we're going to go to the vertex. So we always go to the right one, and my a value is -1, or my new value is -1, so I go down 1, make a point. Then from that point I just made, I go right 1, and the next thing tells me to go down 3, so 1, 2, 3. Then we go right 1, and then down 5. 1, 2, 3, 4, 5. And then we do that on the left side of the vertex as well, so left, and then down 1, left 1, down 3, left 1, down 5. Now, we're going to refer back to our equation. It says y is less than. There is no equal bar, so it's going to be a dashed line. So we're connecting those dots in a dashed line. And now we're going to test a point. So like I said before, I like to test the point 0, 0. And I can use that point because the graph does not pass through it. Again, if the graph passed through that point, then I would not use it. I'll put a little dot on 0, 0 right there. So my test point is going to be 0, 0. So I'm going to take it and substitute it into this quadratic inequality. So y is 0 is less than -0 squared minus 2 times 0 minus 1. So we're going to simplify. 0 is less than, this is 0, and we have a -1. So is 0 less than -1? That is false. Since that is not true, we shade the region that does not include your test point if it is not a solution. So that's not a solution, which is on the outside of the parabola. So we're going to go and shade inside the parabola. Now, if it was true that if that was true, then that means that's a solution. We would have shaded on the outside of the parabola. All right, so there's that first example there. All right, on to the next one. All right, for example 2, we're going to do the exact same thing. First, we're going to start with finding the axis of symmetry for this. So again, a is in front of x squared, which is 1. B is in front of x, which is 2. And c is -8, the constant. So x equals, I'm going to write the formula here since it's on the other side, opposite of b over 2a. So the opposite of my b is -2 over 2 times a, which is 1. So -2 divided by 2 is -1. So for my vertex, we know my x value is -1. And now to get the y value, we're going to substitute -1 into our equation here. So y equals, so we have -1 in parentheses squared, plus 2 times -1 minus 8. Now I'm going to work it out. -1 squared is 1. 2 times -1 is -2 minus 8. So 1 minus 2 is -1. Minus 8 is -9. So my vertex is at -1, -9. So 1, then 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's my vertex. All right, now we're going to look at the a value. We know the a value is 1. So again, we use 1, 3, 5. And this time I may be able to use 7, so I'm going to add that there because it looks like it's going up. So we go, start from the vertex, we go right. And notice I didn't multiply by anything because the number is 1, and anything times 1 is just itself. So right 1, and the first one is a positive 1, so we go up 1. From here we go right 1, the next number is 3, so up 3 because it's positive. And again, we go right 1, up 5. 2, and then right 1, up 7. 3, 4, 5, 6, 7. And then on the left side, we do the same thing. So left 1, up 1. Left 1, up 3. Left 1, up 5. And left 1, up 7. Okay? Now refer back to our inequality sign. It is greater than or equal to. Equal to means that it is a solid line. So we're going to connect our dots with a solid line this time. And there is my graph. Okay? Now from here, we're going to get a test point now to see where we shade. Again, you'll notice the graph did not pass through the origin 0, 0. So that's going to be my test point right here. I'm going to test 0, 0. All right, so let's substitute it into our quadratic inequality. So 0 is greater than or equal to 0 squared plus 2 times 0 minus 8. So 0 is greater than or equal to 0 plus 0 minus 8 is negative 8. This time, 0 is greater than or equal to negative 8, so that is true. So this time we shade the region where the point is. So the test point is in here, so that means I shade inside the parabola. If that came out to be false, then I would have shaded on the outside of the parabola since it wasn't a part of the solution set. Okay, let's take a look at these last two examples here. So again, this is just going to be another one where I'm just going to show you the process through it. All right, so here again, we're going to do the axis symmetry to help us find the vertex. So x equals, again, let me identify A is -1, B is +2, and C is 4. So x equals the opposite of B, so the opposite of 2 is -2, divided by 2 times A, which is -1. So -2 divided by -2 is 1. My vertex, the x value is 1. We're going to substitute it into the function to get our y value. So y equals negative parentheses 1 squared plus 2 times 1 plus 4. And then we get 1 squared is 1, but we have a negative, makes it -1. 2 times 1 is 2 plus 4. So 6 minus 1 is 5. All right, from here, we know our vertex is now 1, 5. So we're going to go ahead and graph that point. So 1, 1, 2, 3, 4, 5. All right, our A value this time again, or this time is -1. So when I do the 1, 3, 5, I have to multiply by the A value of -1. So 1 times -1 is -1, 3 times -1 is -3, 5 times -1 is -5. Now, if we can add the 7, we will, but I'm not sure if we will be able to. All right, we start the vertex, right 1. My first value is -1, so I go down 1. Right 1, then down 3, 1, 2, 3. Right 1, down 5, 1, 2, 3, 4, 5, and then I don't think I can go down 7. So on the other side from the vertex, we go left and then down 1, because that's my first one. Left and then down 3, left and then down 5. All right, now we're going to connect our dots, but before we do that, we gotta know if it's solid or dashed. So we look at the inequality sign, it is greater than. There is no equal bar, so it should be a dashed line. So that is a dashed line there. Again, the point 0, 0 is not being used. So I'm going to test this point right here, 0, 0. And let's see. So test point is 0, 0. Okay, we're going to plug it into our quadratic inequality. So 0 is greater than -0 squared plus 2 times 0 plus 4. So 0 is greater than, that cancels 0, 0, and we have a +4. Is 0 greater than 4? That is not true. So since it's in here, we shade on the outside of the parabola since it's not a part of the solution set. And there is my quadratic inequality graph. All right, we have one last example. So it says, example 4, using a quadratic inequality in real life. So it says a manila rope used for rappelling down a cliff can safely support a weight in pounds provided with this equation. W is less than or equal to 1,480 d squared, where d is the diameter in inches of the rope. Graph the inequality and interpret the solution. Okay, so right now we have a, we have a graph already made for us that represents this equation. Now what we're going to do is we're going to find a test point, and we're going to test it to see where do we shade. Do we shade outside of the parabola or inside of the parabola? Now you'll notice it's only in quadrant 1 because this is a real life application, which is in the first quadrant because they're both positive. So let's go ahead and pick a test point. Let me see. When I look here, an easy one looks like 1, 1,000. So I'm going to use that as my test point to see where I shade. And that's 1.0, 1,000. So now we're going to plug it into this function. So this is W, the weight, is less than or equal to 1480 times 1 squared. So 1,000 is less than or equal to 1480. That is true. So that means the shaded region is on the outside here. Now you notice I didn't use 0, 0 just because the origin actually looks like the graph passes through there, so that's why I didn't use it. But using this point here, 1, 1000, we can see that it checked out to be true, so we know it is shaded below here. Now, so we graph the inequality and interpret the solution. So let's interpret the test point. So the test point is 1, 1000, and again, it tells us D is the diameter in inches of the rope, and W is the weight in pounds of what it can support. So what this says is when the diameter is 1 inch, it can support a weight of 1,480 pounds. All right, and that concludes the notes for today.